In fact, let's go ahead at the top of our paper here and put that zero product property, and your name too if you want to, sure. But let's put that zero product property up here, okay? Because when we solve equations that involve factors, okay, we're going to take advantage of this thing called the zero product property. So let me state it up here. So the zero product property. Okay, very important. And again, it's called the zero product property because the idea is if two things multiply to make zero. Okay, so if the product of two quantities is zero, then one of those two quantities must be zero. Okay. If the product of two quantities is zero, and really I could say if the product of two or more quantities, right? Because you can multiply 3, 4, 5 things together, right? If you have a product of things, and that product eventually is going to equal zero, then at least one of those things must be equal to zero. Okay. So let's take a look here at an equation. Okay, right here. You've got x plus 4 times 3x minus 5 equals 0. And the directions now say solve each equation. Okay? And we know to solve an equation, right, we want to get, what do we want to do with our x? We want to have x, what? By itself. X equals something, right? So if you look at this, this is kind of funky to think about how we might go about getting the x by itself here, right? You might think to yourself, well, what if we add 5 to both sides? Well, the problem is this minus 5 is in parentheses here. So we can't just add 5 and cancel out that minus 5 there. It's in the parentheses with 3x. It's 3x minus 5, right? And then on top of that, it's being multiplied with this x plus 4. So it's like kind of mixed up. You might say, oh, okay, well, let's just multiply it out. And again, I'll show it to you up here on the board because I don't want to write it down there because it's not going to be helpful, and I'll show you why. But if I write it out, x plus, actually, I will write it down, but don't you guys don't write this down, okay? So here, this is wrong. I'm going to write down this is wrong, okay? Not going to be helpful. Well, not helpful, maybe. I'll say that. Okay, so you don't have to write this down if you don't want to, but let me just show you how it's not helpful. If we do x plus 4 times 3x minus 5, right, if I multiply this out, remember we have to do the distribution method here. So I'm going to take this and multiply by 3x and the minus 5. So I'll have 3x times x plus 4, and then minus 5 times the x plus 4. Remember, we multiplied this in the past. Still have the equal 0 here. Okay. Then we'll distribute one more time. 3x times x, 3x times 4, minus 5 times x, minus 5 times 4. We get 3x squared plus 12x, minus 5x, and then minus 20. And they can combine like terms. So 12x minus 5x is 7x, minus 20 equals 0. So you see, we could multiply these things out, and we would get this. Okay? And then, what might we want to do here? If I just like threw this problem at you, and I just said like, solve it, what might you want to do to try and maybe solve this equation? What might be your next step here? What do you guys feel like maybe might be a good next step? Okay, yeah, get the x by itself. So in order to do that, what might you want to do here? What might you guys like to do in a problem like this? If you had to make a next step, what do you think? Okay, so Liv points out a good thing here. We have a problem in that this is x squared and this is x. So these are not like terms. We have two separate x's that we can't put together because one is x squared and one is x. Okay? You could, if you wanted to, add 20 to both sides to kind of have the x's on one side, like this. But now you're kind of stuck. Okay? Now, we could do one more thing here. We could factor this, right? What's the GCF we could factor out here? What's a common factor we could factor out here? An x, right? And if I took an x out of this, I would be left with 3x plus 7. Okay? But here's the catch. I have two things now that multiply, but they multiply to give me 20. If two things multiply and they give me 20, does one of these two things have to be 20? No, right? How can we get 20 without using 20? What can we multiply? 5 and 4. 2 and 10, right? So you see the problem here. If we're equal to 20, if two things multiply, so the x is one of those two things, the 3x plus 7 is the other of the two things, right? I have two things here that are multiplying and trying to give me 20. I can't say anything else because there's other combinations of these two things that could multiply to give me 20. I don't have to say this is 20. I don't have to say that this is 20. So you see it's not helpful. There's too many options here. But let's go back to the original problem that we have. Okay, back to the original one. Okay, do we have two things being multiplied together here? X plus 4 is one of those two. 3x plus minus 5 is the other two. So it's two things that are multiplying together. And what does it equal? What's this product equal? It says 0, right? 0, right? It says it's equal to 0.
Wait, is this one the right one?
Yeah, this is the right way to do it. Yes, you definitely want to write down this one. Yes, sorry, you do want to write this one for sure. Okay? So we have two things that multiply to give me 0. If two things multiply to give me 0, what must one of those two things equal?
0.
0. So either x plus 4 is going to equal 0, or 3x minus 5 has to equal 0. Things like that. Tyler, question? Comment?
Shouldn't the x be 0 then?
So, but it's not x that's multiplying with this to give me 0. It's the quantity x plus 4 that's multiplying with 3x minus 5 to give me 0. So the things that are multiplying are x plus 4 and 3x minus 5. So it's not just the x that's 0, because it's not x times something that gives me 0. It's x plus 4 times 3x minus 5 that gives me 0. Do you see the difference there?
Yes.
Okay. And we'll maybe see an example of what you're talking about a little bit later. But certainly if you see something like this, then yes, either x is 0 or x plus 1 equals 0. Okay? Or, so in other words, here's one of your possible solutions, but then how do we solve here? It's x by itself. How do you get rid of plus 1? Yeah, just subtract 1 from both sides. You get x equals negative 1. So there are two answers here. Two answers. Okay? So let's look here. Okay? We've taken our two factors, and they both could equal 0 to make this equation true. So either this is true, or both could be true as well. So, Mark, if x plus 4 equals 0, Mark, what do we need to do here to solve for x?
You gotta subtract 4.
On both sides, right? Minus 4, minus 4. And so we're left with x equals negative 4. So there's one of our possible solutions. Let's now try this one. Mark, what will we do here to solve for x?
You will add 5 to both sides.
Add 5. And we're left with what over here?
0.
Over on the left-hand side. 3x. And on the right-hand side?
5.
5. Okay. Are we done?
No.
What do we still have to do?
Figure out if it's negative 4 or 5.
No. Well, have we solved for x here yet? Have we finished solving for x?
Oh, no, we haven't. Divide 3.
Divide both sides by 3. That's right. Okay. X equals 5/3. Okay. I'm going to leave it as an improper fraction there. Okay. So, Alex, Mark, what's our solution? Is the answer negative 4? Is the answer 5/3?
Yes, sir. We don't know.
How can we check to see which one's right? Plug it back into the original. Okay, now you're not going to have to do it. So I know, Reagan, you don't want to have to do that. But, Reagan, you'll see what's going to happen here, and you won't have to check every single one if you don't really want to. You still should, but you won't have to. Let me just show you. So let me show you. Right, so let's plug it in here. So I'm going to use some parentheses. So parentheses, -4. 1 second, I'll be right with you. Okay? So you see I plug -4 in for x, parentheses, and then we'll plug -4 in here for this x. So 3 parentheses -4 minus 5. Okay? So you see it there, and it gives me 0. Okay? Let me try the other one. I'll plug in 5/3. So now I'll do parentheses 5/3 plus 4. What's that?
That's not bad.
Yeah.
I thought it was going to be like that longer thing we did before.
No, I'm just plugging it in here, and then I'll also plug it in here. So parentheses 3 parentheses 5/3 minus 5 close parentheses 0 as well. So wait a minute. Both of these, when we plug them back in, give us 0. So what does that mean? What does that mean about our solution? Which one of these are our solution? They both are our solution. We have 2 answers. Okay? Now that's different, right? We normally, when we solve an equation, how many answers do we normally have when we solve an equation? 1. Or every once in a while, we also had infinitely many. If you remember those, right, where we had the x's on the both sides and they cancel out, stuff like that, you get a true statement, right? You could have infinitely many. Here we have 2, right, Alex? Mark? Alex, how about you move over here? Where Miss Mulcahy normally sits. She's not going to be here today, so we're going to give this a try and see how things go. Okay?
It might work successfully.
We'll see.
Not.
Thank you for your... I know, Alex. You're a very friendly kind of guy. All right, number 3. Number 3. We'll see how this goes. Okay, number 3 for right now. All right, so let's try number 3. Now, number 3, again, I see 2 things, x plus 4, x minus 6, and they're being multiplied, and their product is 0. So we have 2 things multiplying to give us 0. What must be true about each one of these things? Yep. They both must equal 0. And sorry, Sean, you had a question. You wanted to ask something. You got it okay now? Okay. So yeah, so we'll say x plus 4 equals 0, and x minus 6, or x minus 6 could be equal to 0. So again, we have 2 things that multiply to give me 0, so I can break it up using that 0 product property here. Up a little more, yeah? Is that good enough? More?
Wait, 3 into 2, right?
We're skipping 2, we're moving down to 3. Right.
2 is going to be
2 will be homework, that's right. All right, Sean, tell me when you're ready so that way I can move on here. Okay. So again, 1 was a product. 2 things that multiplied, and their product was 0. Okay. 3 is also a product. 2 things are being multiplied. X plus 4 times x minus 6, and that entire quantity, that entire product is equal to 0. Yeah. Good? Okay. Number 3. So if those 2 things multiply to give us 0, one of these 2 things is equal to 0. So we set them equal to 0. And now we solve these 2 simple equations. So Catherine, to solve for x here, what we do to both sides? Minus 4. So x is equal to -4. Great job there. Matt S., if we want to solve this one for x, what we do to both sides?
You would
Add 6 to both sides. You got it. X equals 6. So what are our solutions here? Anybody? If you want to say it, Matt, go ahead. What are our solutions? -4 and 6. 2 solutions. Okay? That's different than all the other equations we've ever worked with before. Normally we only have 1 solution. Sometimes we have infinitely many. Sometimes there are no solutions, right? Here this is 2 solutions. That's right. We got to start baby steps. Baby steps. Crawl before you walk.
On the test, do we
Walk
have to
before you run.
both like solutions, or if we only put one?
You need to put both. You need to put both. Because again, what does it say? Solve each. It says solve each equation, Mark. That means you got to give me the solutions. If you miss a solution, you're not giving me all the answers. Got to factoring then. Yep. So we're going to do that right now, Matt. Actually, if you go look at number 5, we're going to do that, an example of that right now. So number 5. Can we use a zero product property right now?
Wait.
We'll get to it. Number 5, at the next top of the next page, can we use a zero product property here? The answer is no. Why not?
Because they're not in parentheses.
We don't have a product of two things that multiply to give me 0. I got a product here, but then I got plus. And I got a product here, but then I got a minus. And I got 12. This is not a product of two things. It's like a product, but then some addition and some subtraction as well. Okay? It's equal to 0. Is that good? Yeah, we want it to equal 0, right? We want to equal 0 to the zero product property. So how can I take this thing and make it a product? Well, go back to what we did in the warm-up. Haven't we taken trinomials before, factored them, and now they're a product? Number 2, haven't we taken a trinomial before, factored it, and so now it's a product? That's what we're going to do here. We're going to factor these trinomials so they become a product, and then that product will equal 0, and then we'll be able to solve. Okay, so we have to, in other words, factor to make a product. Okay? Factor to make a product. So, let's do it here. Let's go to someone. There we go. Let's go to, I'm going to make Kendall do it again. Alex. Alex, to factor this thing, we multiply the 4 to the, or with the?
With the x.
4 times, oh, it does multiply the x, but I mean if we're trying to factor it, though, the strategy we use for factoring, 4 times the, what's that? Times the negative 12. 4 times negative 12, negative 48. Okay? So, Alex, we're looking for two numbers that multiply to negative 48, but add to what?
13.
To 13. That's right. Okay? So, can you think of two numbers that multiply negative 48?
Find a calculator after the 16.
Okay, that's fine.
One would be, I believe it's 8 times 6.
Okay, yeah, 8 and 6. Of course, one has to be positive.
Which is my
Yeah. One has to be,
Probably could get my calculator.
yeah, but in a second, let me just, so one has to be positive, one has to be negative, so let's just make it positive 8 and negative 6. Is that correct, though, Alex? Do they add it to positive 13?
No, they both need to be positive, so one needs to be, I
does-
think it needs to be negative 8, I believe.
Negative 8 and positive 6. Do they add to 13?
Negative.
So no. So positive 8 and negative 6 doesn't work. Negative 8 and positive 6 doesn't work. So we need another pair of numbers. So I'm going to help Alex out. What other pair of numbers could we use to multiply to 3 and 16? So let's try, should we do positive 3 and negative 16 or negative 3 and positive 16? Let's try it this way. Positive 3 and negative 16, do they add to positive 13? Nope. Negative 3 and positive 16, do they add to positive 13? Yes, there's our pair. Okay? So we've got 4x squared minus 3x plus 16x minus 12 equals 0. Okay, Alex, so we got our pair of numbers here that work. Alex, what are we supposed to do now? I broke up that middle term.
The correct number.
Do you want me to go someone else?
Yeah.
Okay. Tyler C. From here, what should we do now, Tyler C?
Alright, so you can split them up?
Yep, group them.
Yeah, group.
First 2, second 2. From the first group, Tyler, what can we take out?
4, x.
Just an x. Very good. So if we take out an x, what will be left inside?
4x and negative 3.
Yep, very good. And then what about from the second group there, Tyler?
We can take out 4.
Yes. And what will be left from, if I divide 16 by that 4, what's left?
4
And then negative 12 divided by 4, minus 3.
Wow.
Okay? Now, they both have 4x minus 3 in common. That's what we want, right? Because now we can factor out the 4x minus 3. And if I take out the 4x minus 3 from both of these terms, what will be left? From here, what will be left?
X plus 4.
X and a plus 4, yeah. Okay, equals 0.
So that's what we've been doing all along.
It's right. It's what we've been doing, okay? But we have one more step now.
But I was correct. Remember when I said plug in the correct number?
We're going to do that at the very end,
No,
yeah,
but
if
like,
you want to.
You said what was the next step directly after
Okay.
you find that number?
Oh, okay, plug them in. I see what you're saying.
Yeah.
Okay, I see what you're saying now. Yes, I already written it up there. That's why I thought you were saying something else because I don't have it up there. So,
Okay.
my bad. Okay, but thank you for helping out with the X plus 4 stuff. All right, so now, do we have a product? Yes. Is it equal to 0? Yes. So we can set each one equal to 0. Each part of the product's equal to 0 there. And now we solve. So, okay, I'll let you guys finish writing that down here. Okay. So this first one here, right, if I want to get the x by itself, Reagan, what would I do here to start getting this x by itself here?
You could. Oh, crap. Hold on.
That's okay. Take some time to think about it if you need to. I know you're busy writing there too.
The
So.
x by itself, right?
Yep.
So then you would add 3.
Add 3 to both sides. You got it. 4x is left here. 0 plus 3 is 0. Sorry, is 3. And then final step here, Reagan.
And then you would divide 4 to both sides.
Yep, divide up by 4 on both sides. You got it. So x is, well, I'm just going to make that the fraction 3/4. Okay? That's one of our answers. Okay? All right, Erica, x
Yeah.
plus 4 equals 0. To solve this for x, what do we do to both sides?
Subtract 4.
Subtract 4. You got it. And you got x equals -4. So how many solutions do we have here? 2. 3/4 and -4. If you plug them back into the original equation here, and I can show it to you. Again, if you really want to see. Okay, 4 parentheses, and I'll put the 3/4 in this time, squared, plus 13 times 3/4 minus 12. Look at that, 0. Okay, I'll try -4. -4. -4. Okay, so there it is. 4, -4 squared plus 13 times -4 minus 12, 0 as well. Okay, so they work. They check out, right? Ready for another one? Keep going here, yeah? Number 7.
Use your mouse again. You're good though.
Good there? Is that enough? Okay. Number 7, okay? Is it a product? No, okay? So we need to make it a product, right? Because it's a trinomial here. So let's see if it factors. All right, so Simon. We're going to take our lead coefficient here, Simon, the 3. And the 3 will multiply with the 4. Yep, so that gives us 12. Simon, we need two numbers, Simon, that multiply to 12 but add to 13. Yeah, you got it. Yeah, it's 12 and 1. That's right. Okay, so just break up that middle term there. Okay, still bring along that equal to 0, right? It's still equal to 0 now. Don't forget to bring down the equal 0 part. Okay, very good. Simon, I'm going to go to someone else here. Let's go to Ben. Ben, now we have that middle term broken up. We want to group, right?
Yep.
And so then, Ben, from that first group, what can we take out?
You can take out the exponent.
Oh, okay. Take out not an exponent. We can take out a variable. They both have an x.
Yeah, that.
Okay, so take out an x. All right, and if I take an x out of 3x squared, I've got 3x left behind. Take an x out of here, I'm left with just 12. Is there anything we can take out of here, Ben?
1. Maybe?
Yeah, just a 1. So let's go ahead and we can put a 1 there. And that's just a 1, actually, that we can take out. Okay, it's going to be the same thing, right? Dividing 1x by 1 leaves you with 1x. Dividing 4 by 1 leaves you with 4. Okay. Ben, was there anything else we could take out of here?
3.
Yeah, divide by a 3. So we'll pull a 3 out front as well. 3x divided by 3 leaves us with just what?
3x divided by 3.
Mm-hmm.
And it's supposed to be
1x. Mm-hmm. And then 12 divided by 3?
3. 4.
4. That's okay. Okay. And now, aha, we have x plus 4. We have 1x plus 4, which is really just x plus 4. So this is good, right? This means it factors. Right, we can factor that. So we'll pull out the x plus 4. And then what will be left behind? If I take an x plus 4 out of this, what's left? 3x plus 1. You got it, Sean. Very good. Okay, do we have a product now? Finally, that's equal to 0? Yes. X plus 4 equals 0. 3x plus 1 equals 0. Okay. Remember, folks, if you factor over here on the left-hand side and you're equal to something other than 0, you messed up. Okay? You can't use that 0 product property for other numbers. You have to have it equal to 0 over here first. Okay? You'll have wasted all that time. You'll be like, darn it. So I'll subtract 1 both sides here. Divide both sides by 3. x equals negative 1/3 is that one, and then negative 4 there. Okay? Question? Yes. You getting this stuff okay? Okay. Then yes.
Good job.
All right, turn the page. Turn the page. If you're ready to move on, turn the page. Okay, number 9, number 11. That's okay. Okay, ready for number 9? Actually, you know what? Let's get down to number 11. We're going to skip down to number 11 because 9 and 11 are very similar. I want you to hold off until I do this one, and then yes. Okay. After him, yes. All right, so 11, okay. This one is different, but similar. Okay, there's some similarities here, but there's a major difference. What is it equal to here? Is it equal to 0? No, it's equal to like 5x plus 6. Do we have a property for when two things multiply to 5x plus 6? No. We have a property for when two things multiply and equal what? Not a number. It's got to equal 0. Got to equal 0. So, in other words, this is not good that I'm not equal to 0 here. I need this to be 0. What can I do to this side to make it equal 0? Subtract what from both sides? 5x from both sides. I'm just going to take it a piece at a time. You can do it all at once if you really want to, though, Dylan. I'm going to take it a piece at a time. Okay, so 2x squared. 6x take away 5x is 1x. Bring down that minus 9. And then the 5x's are gone, and I've got a positive 6 there still. Okay? And then, yeah, to finish making it equal to 0, what should we do to both sides now? Minus 6 on both sides. Okay? And I like to line up what I'm subtracting with like the like term here. So you see I put the minus 5x underneath the 6x because they're like, and I put the minus 6 underneath the minus 9 because they're like, you know, so that's why I did it that way. Minus 9 minus 6 is going to be negative 15. You went a little too high there. Close. I think you forgot to carry the 1, though, or you carried too many 1s. Okay. Is it equal to 0 now? Yes. Is it a product, though? No. So what do we have to do? Starts with an F, rhymes with actor. Factor. That was so bad, I guess. But anyway, you get the idea. Okay, so 2 multiplies with the negative 15, so we get negative 30. We need two numbers that multiply to negative 30 but add to positive 1. That's, yeah, careful. Two numbers that multiply to negative 30 and add to positive 1. Well, we can try, 1 and negative 30. Will that add to positive 1? Nope. We can do negative 1 and positive 30. Does that add to positive 1? No. Nope. We can do 2 and negative 15. Does that add to 1? How about negative 2 and positive 15? No. How about 3 and negative 10? No. How about negative 3 and positive 10? No. 4 doesn't work, right? 4 doesn't divide 30 evenly. How about 5? Negative 5 and positive 6? Wait, yes, it does. Yes, 2x squared minus 5x plus 6x minus 15 equals 0. Yeah, just beat you, huh? Okay. Now, we group it from the first 2 group, here from the second 2 group, okay? Shepherd, what can we take out in common between the first 2 terms here? They both have a what? An x, so we'll take an x out, okay? If I had 2x squared and I take an x out of that, I will have 2x to the first, or just 2x. If I take the x out of this, what is going to be left over here? Yeah, the minus 5. You got it. Shepherd, how about from this group right here, from the 6x and the minus 15? What can divide both of those? 3. Very good. 6 divided by 3 is 2. Negative 15 divided by 3? Yeah, negative 5. Great job.
Good job.
And they match up. 2x minus 5, 2x minus 5. That's good. So we're going to take the 2x minus 5 out. Okay. Mark, what's going to be left over? If I take the 2x minus 5 out of here and out of here, what's left over?
The 3.
X plus 3. Because there's an x here, and there's plus 3 there. Okay. Do we have a product?
Yes.
Is it equal to 0?
Yes.
So set each equal to 0. Okay, and again, just solve. So we'll add 5 to both sides there. Divide both sides by 2. And then subtract 3 on both sides here. Voila. Okay, question here.
Is there always going to be 2 answers?
Good question.
No.
So,
Last problem we didn't have 2 answers.
in the, what's that?
Well, last problem we did have 2 answers, but we
Mhm.
didn't use like one of them. Wasn't used.
Well, he said both are answers. They both do work. They're both solutions on that last one there.
Oh, no.
They do both work. So let's think about this. And like in the past, right, when we first solved equations in this class, right, how many solutions did we have there?
1.
1. What was the highest exponent that we saw in those earlier equations that we did?
2. There weren't even exponents.
There wasn't. So if there's not an exponent, what exponent do we assume is there, right? If your variable, like this x right here, it doesn't have an exponent, what exponent could we write there, though? A 1. Okay? So in the earlier equations, the highest exponent we saw was a 1. And how many solutions did we ever see? 1. Sometimes we had infinitely many, right, if there was the place where the variables canceled out. Here, what's the highest power you see? 2. How many solutions do we have here? 2. Up to 2. So we could actually, there are situations where you have 1. If you have something called like a perfect square, remember we talked about perfect squares earlier? Something like x squared plus 2x plus 1. When you factor this, Hannah, it factors to x plus 1 times x plus 1 equals 0. So you can see it's like a double root. It's the same answer twice. So there's 2, but it just happened, it's the same number. So yes, it's possible. Long story short, it is possible to only have 1. Okay? All right, turn the page. I'm going to just stick for one more, and then I'll let you go. I'm going to make you stay for the whole problem. I just want you to see one more thing. Skip. So 13, real quick, strategy-wise here. 13, just real quick. I'm not going to go through the whole problem. Just 13, strategy. What should we do first? Add 8 to both sides. Why? We must equal 0. And then once you add 8 to both sides, you factor, and then you go from there. Okay? So I'm just going to show that one little step here, and then I'm going to talk about 15 real quick. Again, just a strategy thing, and then I will let you guys get started here on the assignment. I'll cut you loose to go do your own thing. Oops. Mr. Wid, here we go. X squared plus 11x plus 28 equals 0. And so then I'll just put like a dot, dot, dot. I think you guys can do the rest from there, right? But this is important. It's equal to 0, right? Okay? Factors, what I wrote there. Just, okay? He's trying to trick me. All right, so that's 13. I don't want to do it. 15. All right, let's just take a look at 15 here real quick. So a few seconds here. Look at 15, and then I'll let you go, I promise. Just. Okay, 15. I see a product. So x equals 21 or x plus 4 equals 21, right? Two things that multiply together equals 21. That means either x is 21 or x plus 4 is 21, right? What?
It has to be x plus. No. Explain it.
Yes, yeah. It's no, but why? Why can't I do what I did right here? What mistake did I make? It's not 0, right? If two things multiply and give me 21, does that mean one of these things has to be 21? How can we multiply to make 21 without using 21? 7 and 3. Yeah, okay? You didn't use 21. So this has to equal 0. Ooh. So let's see here. In order to make this be 0, what should we do to both sides? Ooh, we never divide by 0, right? That like undoes the universe or whatever kind of thing. Yeah, I can't do that. You ever seen that picture of like a black hole and someone divided by 0 at the bottom of it or something like that? No. Oh, I'll show it to you. It's an old meme. Old memes. Probably before you guys even knew what a meme was.
What were the first memes?
The first memes, one was like a dancing baby. One was this, they were like, so old memes used to be like done in Shockwave, which is like an animation kind of thing that the people would use. So like there wasn't like, because YouTube wasn't really around, so they used like animation, like
What year
Shockwave.
was this created?
One year was memes created. I want to say like the late 90s, I want to say, is when it was like really became big, yeah.
That's pretty old.
I know. It's before you guys were even born.
Ancient times.
Ancient memes.
Was Hitler invading Russia?
Is that a meme?
It is.
Okay. All right. I'm laughing on the inside. Anyway, so what do we do here, though? And we need to make it equal 0. What do we have to do to both sides? Subtract 21. So I'm going to have x times x plus 4 here. Again, minus 21, minus 21. I'm going to have to put a minus 21 there, and that's going to equal 0. Okay, like that. I subtract 21. I can't do 4 minus 21. Why can't I do 4 minus 21 here? It's inside of parentheses. Yeah, we can't do that. So how should we proceed from here? What should be our next step?
Multiply x.
Multiply x with the what?
X and what?
Yeah, distribute the x and the x plus, or distribute the x and x plus 4. So it's x squared plus 4x minus 21 equals 0. Okay? And then now what should we do? It's trinomial, right? So, starts with F, rhymes with tractor. Factor. So we need two numbers that multiply to negative 21 and add to make 4. So 7 and negative 3. You got it. So we have x squared plus 7x. And Mark, you can go now if you want. Thank you for waiting. Group the first two. Group the second two. What can we take from the first group? X. Leave behind x plus 7. Second group.
You can take out a 3. -3.
Yeah, let's make it a negative 3. Very good. Negative 3x divided by negative 3 is just 1x, or x. Negative 21 divided by negative 3, positive 7. Is this what we want?
Yes, sir.
Yes. We got the same
Now
thing.
let's do the work.
Okay? So x plus 7 times x minus 3 equals 0, which means we have two things that are multiplying to give me 0. That means either this one is equal to, if two things multiply and give you 0, that means either this one equals what?
0.
Or this one equals
0.
0. Either x plus 7 equals 0, or x minus 3 equals 0, or it could be both too. All right, subtract 7, add 3 over there. X equals negative 7. X equals 3. Two solutions again.
Why is 16 so long?
Because
You don't have
That's
to
the
do
last
it, right?
question.
I want you to try it, yeah.
A lot of numbers.
It is. It is, Sky. It is. Okay. All right, so for your homework, I want you to do the evens. Okay? The evens. Yeah, that's a good question. That does seem like, yes, I would like you to do all of them, I think. Yes. Okay? 16, I will make a bonus, though. So if you try 16, and I mean really try it, and not just be like, you write the number 3, so see, I tried it. Okay? If you really try number 16, I will give you bonus to your homework grade. Okay?
Ooh, I'll do that.
So, but I want you to do all the other ones, too. So don't, like, only do 16.
Wait, so it's the entire packet?
The evens. The rest of the evens.
Oh,
So all the evens.
What about the ones that you skipped over?
You can forget about those if you want to. So, yep, just the evens.
Can I see number 3?
Yep. Okay, so get to work here, folks, on the evens, and I'll come around and help if you get stuck, or if you want me to check something, I'll be happy to check when Mark comes back. You have to go so bad? If you go when you're at lunch, you won't have to wait. But you know how you can still go even when you don't have to go? You know what I'm saying? Do that, and then you'll have that much less to build on throughout class.
Why did Tyler see me?